the New Frontiers section. So basically, I broke it into two parts, but it is heavily skewed towards the first section. So it's going to be all about transactions. So really trying to understand at a very core level how transactions work, and then sort of building up to these like more complex things that you could build with just these really simple DeFi building blocks, and really trying to go step by step explaining how exactly you might actually build an application that uses these transactions. And then the second part is going to be about accessibility. So I'm just going to give a brief summary about kind of some of the challenges that DeFi currently faces in trying to explain and make these different protocols more accessible and understandable to people. And then finally, I'll do a quick recap of the prizes. So to get started, just a 101 of Aave. Aave is a decentralized, non-custodial liquidity protocol. So in short, it's a place where you can supply assets and earn interest, and you can take on over-collateralized borrow positions. And these positions are secured by a mechanism called liquidations, where if a borrow position does not meet a certain collateralization requirement, someone else can come in and repay the debt of that position and then claim a certain portion of collateral. And it basically creates this autonomous system where the suppliers and borrowers are interacting with each other through this automated contract. And so how do you actually interface with this protocol? So the main point of contact for most integrations is going to be the pool contract. So pool.sol. This is where most of the core functionality of the protocol happens. So most of the core write functions like supply, borrow, repay, withdraw, flash loan. And there's also some helpful read functions like get user account data to fetch the health factor of an address, get reserve data to get addresses, stuff like that. So yeah, this contract is a great place to start. It's also a great place to jump into the code and try to see for yourself kind of how the protocol operates at like a core level. And then this might be the most important slide of the entire thing if you're hoping to build on top of Aave. This link tree lists a ton of different resources, all of the different source code links, different packages, different registries, things just to make your life a lot simpler so you don't have to scrounge for contract addresses and ABIs and try to piece things together. There should be guides and packages for just about everything that you need to do in order to get started with the protocol. So would highly recommend either saving this address or scanning this, this code so that you get access to all of those resources. And then kind of diving into transactions. So if you can think about what goes into creating a transaction, a lot of people think about DeFi as just going to a website and then clicking a few buttons, and then the actions happen. They don't actually consider, the back end, what's actually happening when the user wants to build these transactions. And this is where you really have to start as a developer if you want to, build an application here. So really the way that it works is you have these actions that a user wants to perform. And then they turn this into this transaction data based off of this ABI, which is essentially like the recipe of the contract, specifying the inputs and outputs expected from the functions. And then once you have this raw transaction data, then the user signs this with their wallet address and then submits it to the blockchain. So this is kind of the general high-level overview of transactions, and kind of how you get started with this process depends on where you want to jump in. So if you're more of a front-end developer, you're working in a JavaScript environment, you can check out the Aave Utilities JavaScript SDK. This has a detailed README which explains how you can use these packages to build transactions for common types. So instead of bringing in the ABI contract addresses, you can just do pool.supply. It'll build the transaction data for you, and then you can submit that to a wallet address. And then if you're more focused on the smart contract side of things, I would recommend checking out the Aave Sandbox. This is a way that you can spin up a fork market. So take the current state of a blockchain and then put it in an environment where you can modify anything that you want. You can send yourself any amount of tokens. You can modify the block timestamp, the block number, anything that you want to test applications and contracts. And this is just a great way to interact with the protocol in a way that is just super easy and free to use. And then if you're more interested in the data side of things, the best place to get data if you want to replicate like what you see on app.aave.com or kind of the core high-level numbers is these UI pool data provider and UI incentive data provider contracts. It's kind of a mouthful. But basically, these contracts will return an array of values. So the pool contract will return an array of the reserves. So that would be all of the tokens inside of a market, all of the data about these tokens, and same for a lot of these other methods. It basically is just a catch-all function to return any data you might want to show on a front end. And then using that same Aave Utilities SDK, also has different methods for easily fetching and formatting these values. So actually, I mentioned this here. So yeah, basically you would call these contracts using whatever libraries you're most familiar with, Ethers, Web3.js, Web3.py. And then the utilities SDK that I mentioned is basically just a wrapper around Ethers, which gives you specific endpoints for just calling Aave methods. It just makes it a lot easier to integrate. And then for historical data, there's a couple different options. The Aave protocol subgraphs is a GraphQL endpoint of index data, but then there's also other index services like Dune Analytics, or you can also just query the events yourselves. You can use things like block filtering directly on the RPC or using an API such as Etherscan. And this is just one example of a good historical data project called Token Terminal. They have some awesome dashboards about Aave and different DeFi projects. So yeah, diving into the new frontier section. So first we're going to dive into transaction building. I kind of already gave a little bit of the demo of the basics of transactions, but we're going to go a little bit further even and then explore some ideas of more complex transactions. And then briefly talk about accessibility, making DeFi easy to understand, easier to use. So for transaction building, a lot of times we like to think about it as like this one catch-all thing. You just, build the data, submit the transaction, but really there's kind of three like guiding principles that you need to know when building transactions. So one is that ETH is a special asset. Or if you're on, say, the Polygon blockchain, Matic would be your special asset. Whatever the base token for your network is going to have special rules and logic for how to interact with it. And so in order to send ETH, your transaction is extremely simple. It looks just like this. It's basically a to address, a from address, the value you're sending, and then information about the gas. And this is all the logic that executes if you want to send ETH to somebody, basically. Where things get more complicated is when you want to actually call a smart contract. So this is the second kind of transaction. And the difference between this and transferring ETH is that you're specifying a data field. And this data field is sort of what we briefly mentioned in the beginning, which is that it takes whatever action you want to call, the function selector. This specifies what contract you want, or specifies the method that you would like to call on this contract. And then everything past this point is the parameters which you're going to pass to this method. So combined inside of this, jumbled mess of hex characters could be supplying tokens, swapping tokens, purchasing an NFT, not specific to Aave. It could be calling any smart contract method. And you can combine calls inside of here. The last thing that you need to be aware of for transactions is token approvals. So anytime that tokens are going to be transferred from a user's wallet to a contract, that token transfer needs to be approved. And there's two ways that you can do this. First is an approval transaction. So this is an actual transaction that you submit in your wallet. It costs gas. And basically, if you approve a contract for an infinite allowance, this allowance will just go on forever. Like it can be used for any amount of any transfer. A signature-based approval is done entirely off-chain. The user signs a permit message, which is basically just a piece of data which specifies the contract that's spending, what token it is, the amount, the deadline, the exact nonce, so the order of the transaction, and it signs it into this. It signs it into a string. which then you're going to deconstruct and then pass to your contract. And essentially, this gives you a lot of different benefits. So the main obvious benefit is that users don't have to pay gas in order to approve their tokens. They only need to submit one transaction to actually perform the action. And we'll get into sort of the even bigger picture benefit of this in a couple slides. So we have our first transaction that we looked at of just supplying wrapped ETH. Now, say, for example, you wanted to create your own contract. You wanted to actually interact with the protocol contracts, and you created this contract with a function called execute. I don't know why you would want to build this function, but basically it just supplies assets and then borrows assets. And then we take this completely separate contract, not affiliated with the Aave protocol in any way, could be any protocol on the blockchain. And it's just a simple contract, and we're going to write the message, hello world. So how would this transaction look if you actually wanted to submit this to the blockchain? So essentially, you'd be bundling all three of these actions into a single message and combining all three of these contract calls into one piece of data for the user to sign. And basically, if you were to do this, the old way without creating a new contract to do this, there would be so many different steps. You would have to approve the pool contract to spend your Aave tokens, supply the Aave, borrow USDC, and then call this write message function. 4 separate interactions where your user has to pay. If you combine this into a bundling contract, which is what I'm calling this, like your contract.sol on the previous thing, what this example showed is that you can actually use this permit-based approach to approve the supply of Aave tokens and approve this contract to borrow on behalf of the user. And the end result is that instead of executing these 4 paid transactions, your user just has to sign 2 messages. And now either they can submit the transaction or it can actually be submitted by somebody else. And this is really kind of the killer use case of permit and message signing that I was kind of alluding to on the first thing, is that when you have these permit messages that can be signed, what you are allowing is for delegated execution. So what you're doing is you're allowing this transaction to now be submitted by somebody else. So somebody else can supply tokens on my behalf, or borrow on my behalf, or repay on my behalf, because I am granting them the approval based off of this signature. And so within the Aave protocol, what makes it really nice for composing these transactions is that all 4 of the main actions of the protocol allow you to build these pieces in a way that all of the logic gets executed on side of your contract. And so if you wanted to, you could build a system where the user can interact with the Aave protocol and never have to pay any gas. All they do is sign messages, and then your backend or your system, whatever you build, would actually pay for the transactions themselves. And this is sort of just like the untapped potential, the exploring possibilities of like what is possible with transactions. And so now I spent a whole bunch of time on that section, and we're going to fly through this. This is just one simple slide. And basically, it's meant to drive the point home that DeFi is still so early in its adoption. And I think it's very crucial to realize that when you're talking about these systems, that the technology is still so new to so many people that diving straight in and just talking about these killer use cases and all of these complex applications might not be the right approach. Sometimes taking a step back and looking at things through a simpler lens, and really just trying to understand what is happening and how can I verify what is happening is the most important thing when it comes to DeFi. The entire reason that these systems exist is to become fault tolerant and censorship resistant. So essentially, we want to build these projects which will basically outlast their developers. The code itself can execute the same way forever. And I think it's important to keep those kind of principles in mind when you're sort of building these applications, is that we want to keep them as sort of simple and general as possible and explain them to the fullest so that anybody can use it and anybody can also, dig into it and figure out exactly what's going on. So with that, oh, good. I thought I left the headers out. But we have 2 hackathon prizes. So the first is for building a simple UI, and the second is for transaction building. So each of them are 2,500. For the simple UI, essentially this is just enabling new users to access the Aave protocol. So basically, if you can think about the scope of all of the users of DeFi today is obviously pretty narrow. There's a lot of users which either aren't DeFi native or aren't crypto native at all, who might be interested in learning about this technology and interacting with it. So for this prize category, it's basically just creating a different form of UI, a different way to interact with the protocol, novel, simpler ways to do things, and then obviously promoting safe Web3 practices. So, verifying contracts, doing things on test nets, showing users what transaction data they're signing, and then, giving comprehensive explanations. Those are all good things to include in a simple UI. And then for transaction building, this is basically what I explained, implementing novel forms of transactions. So this could be combining existing actions like the supply and borrow and repay into ways that haven't been done before, extending or batching features, or could be pulling in a completely different block. So in that slide where I showed like that high dot solidity contract, taking in a completely different contract outside of the Aave protocol and integrating some transaction with it. This QR code is the same one I linked earlier, but very important if you want to get started with resources. And then obviously Aave developer docs have some great stuff in there as well. And then the Aave Grants DAO, if you're interested, kind of post hackathon, has a lot of requests for proposals and also openings for different types of applications for sponsorship. So, yep, that's the end of the presentation. So thanks. Oh, should we have some time for Q&A?
Yep, I can help read that out for you. So I'm just opening the Q&A box. I can see 3 questions already. We have one question from Pranay. He asks, does bundling signing messages cost less gas?
So there's kind of 2 separate steps to this. So the first step is actually signing the messages. This costs no gas. So like in the example I gave where you were supplying Aave and then borrowing a token, you would just sign 2 different messages. Neither of those cost anything. And then when you actually submit the transaction, that bundled transaction, what I think you're asking is if the bundled transaction costs less than doing them individually. And yes, it is cheaper to bundle them together than to call them one by one individually.
Got it. Then we have another question from Snehal. Can you explain how signing messages work?
Yeah, so this could get into a whole other talk in itself, but basically the high level of how it works is that the message is just a piece of data. It's an object that says, here is what I'm signing. Usually it'll have, the name of the contract, the name of the token, a thing called the nonce, which is the order within your wallet, the deadline of the signature, and the user takes their private key and then signs this message. The most common for like JavaScript libraries is called sign typed data. When you call sign typed data on this object and the user signs it in their wallet, it generates this signature, which you can then decompose and pass to a function. There's actually examples inside of the Aave utilities repo for how to generate a message signature yourself. So if you are looking to implement that, that's a good place to start.
Awesome. Then we have another question from Anirudh. Could you please explain how Relayer is implemented in a more elaborate manner?
Yeah, so relays are super, super interesting. Basically how they work is that you have these transactions which are already signed by the user. So you already have a valid signature from the user. The step that's left to do is to then take that transaction and submit it to the blockchain. And so you could do this in a lot of different ways. Essentially, what a lot of projects do is they will have a backend where basically they store these signatures, and then they'll use something like an Open Zeppelin Defender. Open Zeppelin is a project that they're most known for contract audits, but they also do a lot of different tasks for automation. And they have kind of just this standard relayer setup where you're able to essentially execute transactions kind of out of sight, out of mind. So instead of manually executing them, it executes them on schedules. And so that's kind of how you would implement a relayer. Is you'd have users sign messages on the front end, they would get sent to a back end, and then the back end would send the messages to the blockchain.
Great. Cool then. I think if you can also go back to the slide which has the QR code for the resources, I think the link tree, I think people just want to revisit that. They just want to take maybe a screenshot or something. Yep. So folks, here's your chance. You can just take up this link. Meanwhile, let me see if there are any more questions. All right. So in the chat, I can see Arunava, if I'm pronouncing that correctly, asking, hi, firstly, thanks for the awesome presentation. I was exploring Aave for a few days now and was going through flash loans. Can you help me with where do I add the custom logic to swap tokens between, let's say, Uniswap and SushiSwap?
Yeah, so this is a very common question. We get this a lot. So basically, the first place to start is definitely the Aave docs. So the Aave Flash Loan docs gives you these sample contracts for understanding in detail like how Flash Loan works, what you can and can't do with them, and then these starter templates. And then from there, if you want to actually build like what you described, having custom logic to swap tokens between Uniswap and SushiSwap, definitely GitHub is your best friend. If you can think of a different type of arbitrage contract, somebody has probably coded it before. But the general step is that inside of your Flash Loan contract, you have this callback called execute operation. And inside of there, you can basically run any contract logic you want. So it's basically would be just like calling swap in any other contract. You can think of it like you can totally ignore that you're doing anything with a Flash Loan and just swapping two tokens. And you can do that inside the function. So that's kind of how it works.
Awesome. I hope, Arunava, that answered your question. We have a follow-up question from Anirudh, which is related to the relayering answer. So having does having a backend mean that it ends up being centralized? How do we avoid that?
Yeah, so that's an awesome question. Basically, in its current status, it's kind of unavoidable. There are some different projects which are, attempting to do decentralized relaying, but there is an EIP which is coming very soon. It's going to bother me. I don't remember the number, but if you just look up like account abstraction EIP,
I believe that's 4337, if I'm not wrong.
4337. That sounds right. But yeah, essentially what this EIP is doing is it's trying to make a way for users to submit these, essentially, I forget what they call them, but they're basically just individual actions. It's not like a transaction where you're submitting the entire thing. It's just an individual action stub that you're basically submitting, and they can be picked up by this network of essentially like MEV bots, which execute them. So it's meant to be like relaying in this decentralized way. It's a really interesting EIP, though, if you want to check it out.
Great. I think we have time for one last question, and that has come in from Manas. How do you transfer Aave positions from one address to another?
Yeah, so there's a couple different like types of scenarios. So the easiest one is, say you just have tokens supplied. Then it's super simple. A tokens are just like any other ERC20. You can just transfer them to another address. But if you have borrow positions, then things get a little bit more complicated. And so the way to do it then is you actually have to take a flash loan. So you would take a flash loan, repay the borrow positions, withdraw the collateral, and then move everything and reconcile them on whatever you're moving it to. So yeah, basically the short answer is if it's a simple position, you can just transfer the tokens. If it's more complex, then you have to do things like a flash loan.
Awesome. Cool. Then I think that was it for today. First of all, thanks a lot, DeFi Spartan, for taking out the time and making it to the ETH for All workshop. I'm pretty sure a lot of folks here got to learn a lot, and then definitely like they would be building on DeFi, on Aave for the hackathon. And yeah, thanks a lot for being here.
Yeah, awesome to hear. Thanks for having me.
All right. So folks, the Aave team would also be on the ETH for All Discord. So if you have any questions, feel free to tag them. And yep, that's it for today. Thanks, everyone. All right. Bye-bye. Thanks, Gokul.